let me hook up the scan tool, and we're just going to sort of reproduce the voltage measurements, but I just wanted to show the voltage measurements for people that don't have the scan tool. We're going to do some things that involve removing the map sensor and experimenting a little bit. And I don't want to do the voltage measurements with that because there's too much chance of crossing my leads up. So for safety, we're just going to do everything from the scan tool. But really, it's the same thing. It's just kind of going to read from the voltmeter measurements and give an interpreted value for the map sensor. So let's look at what we get. Okay, so what I'm using is Auto Ingenuity as my scan tool here. And what we are looking at in this left corner up here is going to be the intake manifold pressure. Much to my surprise, there actually is not a voltage measurement that is an option on my scan tool. Generally, there will be a voltage measurement, but either way, it's the same thing. This manifold pressure measurement is going to be low right now at idle, but of course we're going to see the same phenomenon. If I step on the gas pedal, let more air in, we're going to see this number increase. I don't really know how much, but it is definitely going to increase. And then when I let off on the pedal, the decel condition, it's going to go below a measurement of 9 inches of mercury. So let's go ahead and just validate that real quick. Okay, so either way that we do it, either with the scan tool or with the voltmeter, we can see that we have, if nothing else, we do know this. While we may not know what the values should be, hey, maybe these values are way off, and if you had a map sensor check engine light, it's because these values are out of, they're out of order. But one thing we do know, just from the voltmeter alone, because we have variance in the signal wire, we know that our electrical connection to the map is good. We know we have a 5-volt reference signal getting to the map. We know we've got a ground, and we know we've got variance in the signal. So we at least know our electrical is solid to the computer. That we do know for sure. But there could, of course, be some calibration issues with the sensor itself. So we might be able to do some things to look at that. One way that we could look at a calibration is using this PID over here. We could look at the barometric pressure, and seeing that the barometric pressure is reasonable, we would know that the map sensor is calibrated properly. So that would be another way to check the map sensor. Again, pretty rare that you're going to have a map sensor issue to begin with. As you can see, the map sensor reacts greatly to engine conditions. So you have that thing where, is your map sensor reporting an engine problem? For example, if I were to make this engine really stumble by maybe removing a spark plug wire and causing a misfire, that's going to have a dramatic effect on my map sensor reading, but the map sensor would not be the problem. The map sensor would just be reporting an issue, and you might get some type of out-of-range map code or something possibly. More likely you'd, of course, easily identify that from the misfire code, though. But let's do another experiment here real quick. What I'm going to do is show sort of some manual manipulation of the map sensor and see how our scan tool reacts. So what I'm going to do is come over here, and what I'm going to do is just pull off this vacuum hose right here to the intake manifold. Now, when I remove that vacuum hose, what would we expect to see from the map sensor? I'll give you a second while I go ahead and grab this here. Okay, and if you guessed that we are going to see this map sensor increase, then you are correct. We will see it increase because we are going to draw more air into the intake. I almost killed the engine there. And there's our decel condition, by the way. But you can see that there's a vacuum leak. We do indeed increase. So that's how the map responds to a vacuum leak. So if you have a vacuum leak and you continually have a high map sensor reading that maybe even sends a code, is that the map sensor that's faulty? Absolutely not. The map sensor is just reacting and reporting another condition, and it is not at fault for the problem. It is just reporting the problem. So you can see how you might get a map sensor code from a vacuum leak, but not have a map sensor problem. Now, of course, another thing that we can do is this. Now, what I'm going to do here is, for you guys that are really advanced and you saw my fuel trims video, we're going to do something a little special for you. Let's pull up the short-term fuel trim here. And this car is actually relatively new, so it's actually at a perfect short-term fuel trim. And here's what I am going to do. I am going to actually remove the map sensor and then plug the hole with a stopper, and just let the map sensor sit outside of the engine. But there will be no vacuum leak because I'm going to seal the hole up. What do you think that is going to do to my fuel trim when the map sensor is actually outside of the engine at idle and there are no vacuum leaks? What would that do to my fuel trim? Think about that while I go ahead and set this up. Okay, and if you guessed that the fuel trim is going to go negative, in other words, we are going to create a rich condition, you are absolutely right. Let me go ahead and cause this to happen first, and then I will explain to you why that is the result we would get. All right, so let me go ahead and get this off of here. And I imagine that we're probably going to kill the engine with the massive vacuum leak that we're going to get. Try to do this real quick. Oh, that was pretty slick. Okay. Now let's go ahead and look at our fuel trim. Okay, so as you saw, it did indeed go rich. Not hugely rich, maybe as you would expect, but you have to remember this engine is also a MAF engine, so it's getting more of its airflow data from the mass airflow sensor. So the map probably not really affected the fuel trim as much. But you can imagine if I had a map only engine, or if I disconnected the mass airflow sensor, well, actually I'd imagine probably the engine would die at that point, I think. But either way, we saw that as predicted, we got the rich fuel trim. So let's talk about why that happened in case you don't understand. All right, and this concept is going to be extremely important actually, because variances in the map sensor are often predicted by the computer, and also they are expected by the computer. So there's a little difference there. And if things that are expected by the computer are not showing, then the computer is going to start looking for someone to blame. Maybe it'll be the map sensor, maybe it'll be something else. But let's talk about that rich condition that we had for those of you guys that are more advanced and familiar with fuel trims. So what happens is, of course, we've got the engine idling, everything's normal, we've got some air coming in. Our map sensor is about, 1.5 volts, I think, is what it is normally at idle on this vehicle. And actually that's voltage there. Let me put it to 8, because that is the inches of mercury that we saw on the scan tool. I want to keep consistent with the scan tool. So we're in our normal idle condition here. And then what did I do? Well, what I did was I took the map sensor and I plugged that vacuum leak up. So my map sensor is now open to just atmospheric pressure. Okay, now what does this do? Well, as far as the air coming into the engine, that has not changed. We still have the same amount of air coming into the engine. But the problem is the amount of air that's increasing the pressure in the map sensor has dramatically increased. So at that signal wire, it's going to increase the voltage because the map sensor is reading a lot more air coming in and increasing the pressure, but the engine itself does not actually have that happening. So when this higher voltage gets to the PCM, it's going to start adding fuel because the computer thinks this is because more air is coming in. and therefore it's going to increase the injector pulse length to increase fuel. Now, when that increased fuel gets in there, remember we were at 14.7 to 1 just fine. But now with the added fuel coming in, but no extra air coming in, this ratio is going to be way off, maybe 14.7 to 3, who knows. But whatever the case is, it's a rich condition that is going to be detected by the O2 sensor. So the O2 sensor is going to feed back to the PCM. If you are familiar with my fuel trim video, it explains all this. And the PCM is going to then show a long-term and short-term fuel trim as rich, and it's going to want to scale back the fuel delivery. Now, it doesn't know why there is this rich condition. Do you see where in this event you might get a throttle position error code? Because the engine has to be thinking there's a lot more air coming in, but the throttle is still showing as closed. So depending on the programming that the engineers put into the PCMs, you may get any number of different check engine light codes, maybe not even for the map sensor on that condition, but that could have well been a map sensor code. Do you see how this could happen if that hose became disconnected? You would of course still have a vacuum leak, so it would be a little different condition than this. But you can see where you can have codes for things that are caused by the map sensor that are not those things' fault, and you can have things at fault that give a code to the map sensor when the map sensor is not at fault. So it's very important to understand fully how the map sensor integrates with all of this complex system before you start replacing a map sensor in the car. Because even though, as we saw, it's very easy, it is bad practice and it can be expensive, and it certainly is not the philosophy of this channel. All right, so pretty much all of that said, you can see where it is very difficult sometimes to interpret a map sensor problem, because the map not only can cause various engine effects, as we saw, but more importantly, the map sensor responds to engine conditions. So there's always that difficulty of, are you reading a fault code for a map sensor? Is that a response to the engine condition that the map sensor is accurately reporting, or is there an engine condition that is resulting because you have a map sensor problem? So it can be very difficult, but as you can see, I've shown you many ways to validate the electricity to the map sensor, validate the map sensor output itself, verify that the map sensor is responding as anticipated to conditions, and, at least on this car, some anticipated values that you would expect. So, hopefully that will help you in your diagnosis. Obviously, I'm not a huge fan of, what are they called, flow charts, where you can see where a flow chart would be sort of problematic on a map sensor, because there's so many variables that you can eliminate right off the bat and sort of bypass 90% of your flow chart. But, honestly, flow charts are for people that do not understand the parts that they are troubleshooting, or even the concepts that they're trying to troubleshoot. Not that there's anything wrong with a flowchart. I like flowcharts, they can be helpful. But the idea is, if you've spent this time watching this video and understanding, then you can make your own flowchart that is custom to the particular diagnosis that you're trying to make. And that's what I really hope that I'm helping you guys to do. So that pretty much covers it for the map sensor. Hopefully you're an expert in that now, and you can use it not only to, this knowledge to diagnose a map sensor problem, but also you can see where you could possibly use the map sensor to help diagnose other things in the engine if you know that the map sensor is working. So hopefully it's taken some of that mystery out of this little talked about component in the engine controls. So thanks for watching. I hope you found this helpful.